All right, we are on the second video for here, false positive, false negative on page 155. So we're going to deal with drug testing here. Now, they give you the information. You got 20,000 total employees. You got 500 employees using illegal drugs. You know that. The drug test they use has a 95% accuracy rate. Go ahead and fill out the table. Now, I would like you to hit pause and try this, and then come back. Make sure your table is correct before you answer any questions. So try the table first, and then come back. All right, so the first part of this is that they tell you, 500 people are using drugs. Well, if 500 are using drugs, 20,000 minus 500 means you have 19,500 who are not using drugs. So, hey, that's positive. Now, when you talk about this, we have a 95% accuracy rate. If they are using drugs, we expect them to test positive, right? So this is where 95% of those that are doing drugs will test positive, right? That's our accuracy rate. So 475 of them will test positive. Let me use a different color for that. 475 will test positive. Now, with that, well, if 475 test positive, that means 25 of them will test negative. So you've got 25 drug users who will test negative for drugs. Now, those that are not using drugs, we expect them to test negative. So the 95% accuracy rate times the 19,500 people not using drugs, and that will give you the 18,525 employees who will test negative. That should, right? Okay, but unfortunately, if you take the 19,500 who don't do drugs, subtract the 18,525 who tested negative, you will have 975 of them that test positive. All right, so that's kind of sad. So when we total those up, there will be 1,450 positive results and 18,550 negative results. All right, so that's what your table should look like, and of course, you don't have to have these blues on here. That's kind of up to you. Let me make these better. All right, so that's what your table should look like with your numbers. Now I want you to go ahead and answer the 4 questions at the bottom of this page. All right, let's look at these questions. If someone tests positive for drugs, okay, so they're testing positive. So that means our denominator is 1450. Probability that they are not taking drugs, so that is 975, and that gives us a decimal of 0.672. If someone tests negative for drugs, denominator 18,550, what is the probability they are actually doing drugs? Well, that means your numerator would be 25, and you would get a 0.001, right? Very, very small probability for that to actually happen. Okay, if someone is taking drugs, so we know that, here, let's do this one down here. There are 500 people taking drugs. What's the likelihood the test results will be positive? Well, 475, and hopefully you knew before we even started that answer was 0.95, because that's the accuracy rate. If you're taking drugs, you will test positive 95% of the time. Now, in number 4, which is worse in this case, false positive, false negative, I don't think there's much discussion. I think the false positive is definitely worse. There are some companies who have a no tolerance policy. If you test positive for drugs, you're out. And while sometimes I think that is a really good policy, you've got a 67% chance of testing positive when you actually have no business testing positive. So, I think if you test positive for drugs and you lose your job and you're clean as a whistle, that to me is definitely a problem, right? That is not a good situation for anybody to be in. All right, let's look at page 156. All right, now in this example here on page 156, we now see that 26% of this population has HIV. So they don't tell us 500 have it. They tell us 26%. So we now have to use the word of, right? So to find the number that have HIV, 26% of the population. So we multiply by the 100,000, and that will give us the 26,000 that are expected to have HIV. So if I would then, to find this number, take my 100,000 minus the 26,000, I know that 74,000 people are expected to not have HIV. All right, so now when I look inside my table, we know we have a 99% accuracy rate. So 99% of those that have it will test positive. So the number that will test positive is 25,740. Well, if 26,000 people have HIV and 25,740 of them do not have HIV, well, gosh darn it, 26,000 of them have HIV. 25,740 test positive for HIV. That means 260 will test negative for HIV. Remember, going across, those two have to add together to get 26,000. Now, for those who do not have HIV, we still have a 99% accuracy rate. So 0.99 times the 74,000 will give us this number in here, which is 73,260. So that means roughly 740 individuals in Swaziland will test positive for HIV even though they don't have it. So when I go to find my totals, the total number of positive tests will be 26,480, and the total number of negative tests will be 73,520. And those two totals will give us 100,000. All right, now using that table, please answer the questions numbers 1 through 6, bottom of page 156. All right, number 1, what is the probability of having HIV if given a positive test result? So a positive test has a denominator of 26,480, and having HIV is 25,740. So when you divide that, you get 0.972. So if you test positive, there's a 97% chance that you actually have it. That's pretty high. Number 2, what's the probability of not having HIV if given a positive test result? Well, we can do our complement, 0.028, or you could have done the 740 over 26,480, right? Either way. Number 3, probability of having HIV if given a negative test result. So having it over the negative, 73,520, and we get a decimal. I'm going to take it out to 4 places because it's just small. If you went to 3, that's fine. And then number 4, probability of not having HIV if given a negative test result. Well, I'm going to use my complement concept, and I get 0.9965. So if you don't have HIV, if you test negative for not having HIV, there's a pretty good chance that you don't have it. Now, how is this different from the HIV in America example? So that was in video 1. And I don't know if you remember, but using number 1 here, right, if you test positive in Swaziland, there is a 97% chance that you have it. In the U.S., so this was in Swazi, in the U.S., that same thing, testing positive, it was only 0.332. So you had a better chance of testing positive and not having HIV than the other way around, right? Whereas in Swaziland, if you test positive, you have it, right? I mean, 97%. It's crazy. In number 6 here, would it make sense for Swaziland to have mandatory HIV testing for pregnant women? I don't know. I mean, with their high percentage of people having it and the test being so accurate, you know, I guess you could make a case for yes, but I don't know. That's a little bit outside of my scope of comfort of whether or not that's really something important. So let's go to page 157. All right, so we've got some cheaters here. We are dealing with 1,000 total students. And Professor Ivy says 2% of them are cheaters. So here's my cheaters. That means the total, 2%. So 2% of the students, of means multiply, means we have cheaters. So 20 students are cheaters. Cheater, cheater, pumpkin eater. And that means 980 students are not cheaters. Right? So we would expect, we have a 95% accuracy rate for this program. So if you are a cheater, we would expect the computer to detect you 95% of the time. So to find the cheater thing here, 95% of the cheaters will be caught, right? Well, basically. And so that's 19. Well, that means there is one cheater who the computer will not detect, right? They are like the supreme cheaterson. If it shows negative for non-cheaters, again, that's 95% of the time. So for this spot, well, let's do that one in red, this in red, it would be 95% of the 980, which would end up being 931. So if 931 not cheaters and it's showing negative, then there are 49, very sad students who they're saying, you cheated, but actually they didn't. So when I total these up, I've got 68 students who the computer says is cheating, and 932 that the computer says is not cheating. All right, use this thing to answer questions 2 and 3 on the bottom of page 157. Okay, and number 2, the computer program says you cheated. That is horrible. Explain to Professor Ivy what the chances are that you've been wrongfully accused. Oh, I have an extra word. Oh, wow. Okay, whatever. And what is the type of test called? Okay, so they said you cheated, you swear you didn't. So, the non-cheaters over the positive test results. This comes out to be 0.721. So basically, 72.1% of positive results are wrong. All right, there's your argument to Professor Ivy. Now that doesn't mean she'll listen, but that's your argument. And what is this called, my friends? That is correct. This is called a false positive. Because you are being told that yes, you are the cheater, when in fact you are not the cheater. And number 3, the director of the assessment center doesn't want to purchase the cheat detector because spell check, because he thinks 5% of students will get away with cheating. Explain to him what the probability is that if a student gets a negative test result that they got away with cheating. And what is this type of test called? All right, so we're looking at the negative test results. So one of those people that got a negative test result was actually a big fat cheater face. So that comes out to be 0.001. So only 0.1% of negative results are wrong. So while the assessment center director says 5% are going to get away with cheating, no, they're not. 0.1% are going to get away with cheating, because those are the ones that are going to get a negative result when really they should have gotten a positive result. So it's really not nearly as big as you think. And as we know, this is called a false negative, because you were told that no, you didn't cheat, when really you were a big fat cheater face. And this, my friends, is the end of section 17, false positive, false negative.